We can write down Avogadro's number, but I don't think we have any real experience with a number that large. I can imagine going to the football stadium, which holds around 60,000 people. I understand what 60,000 things are. I might even imagine 10 football stadiums in a row, but even that number of people is getting a little out of range of my experience. This Avogadro's number, this is not 600,000 or 6 million or 6 billion or 6 trillion or 6 quadrillion or 6 pentillion or 6 hexillion. This is 602 hexillion things. We can't really fathom a number that large. It's been said that if you took popcorn kernels, a mole of popcorn kernels, and spread them across the United States, they would form a layer 8 miles deep. We really don't have any experience with a number that large. This mole, this Avogadro's number, is an unfathomably large number. Now here are some bottles with moles of different elements. On the left is a mole of carbon, it's a graphite rod. Then a mole of tin, a mole of sulfur, nice yellow powder, a mole of iron, looks like a bottle of nails, and a mole of aluminum. Now imagine taking this graphite rod and breaking it in half and then in half again and again, not a million times or a billion times, but 602 hexillion times. Imagine how small those pieces must be. Well, actually, we can't imagine that. We can't relate to anything that small. An atom is an unimaginably small object. But the beauty of a mole is that if we take an unfathomably large number of unimaginably small objects, we have an amount we can hold in our hand. I can relate to a mole of carbon. And this idea of atoms and moles illustrates what I like to call the first pillar of chemistry, the first basic idea that we will see over and over again throughout the course. Our first pillar of chemistry recognizes these two vastly different scales. We encounter atoms on the mole scale, or what we might call the macroscopic scale. When we count atoms and molecules that we measure in the lab, we count by moles. But chemistry happens on the atomic scale, or what we might call the nanoscopic scale. How the individual atoms and molecules act when they encounter each other one by one dictates what happens in chemistry. We must think on both scales. We do our experiments on the mole scale, but at the same time have to think about what is going on at the atomic scale. The point here is that atoms and molecules exist in an entirely different realm than do we. But this course invites us down into the realm of atoms and molecules to explore what they are doing. We might find that reality on the atomic scale is curiously different than what we experience here on the macroscopic scale. But recognizing this and accepting this as a possibility will make things much easier for us.